Thank you, sir, for a very nice mention and great presentation. So today my topic is hydrogen safety both in design and use. See, hydrogen is coming into our life in a big way. And as per our Honorable Prime Minister, about 5 million ton of hydrogen by 2030 is the target. That's the national policy. We can't walk away from it. So now 5 million ton doesn't sound much, but considering hydrogen is one-eighth the weight of oxygen, it's about equivalent to 40 million ton of oxygen in 5 years. Now, that much of hydrogen will encompass all aspects of our life, from transportation to space use to pharmaceuticals to semiconductors to other many furnaces as fuel, because that gives you a lot of carbon credit. So now, are we ready to accept this new gas into our world? Right? It is an established industrial gas that we have been giving a hydrogen system or equipment to ISRO for the last 20 years. But it is not a widely used gas as such. As a gas, yes, but in the liquid form, no. So the liquid form also it will come. So it is time maybe we just recapitulate what are the factors which make hydrogen different and how scared or careful we should be when using it in our day-to-day use. Hydrogen safety involves managing its high flammability. It's highly flammable, it catches fire very quickly. Through rigorous engineering controls like ventilation, leak detection, material selection to prevent embrittlement, alongside strict protocols such as grounding to avoid static discharge. This we normally don't do. Right? The rule is there, but many places they just connect the hose and transfer. That is strictly not allowed in hydrogen service, liquid hydrogen also. Special flame detectors, like normal flame detectors detect the visible fire. But for hydrogen, we need multispectral flame detectors, which UV, infrared, and of course visible spectrum. So it will shut down the transfer process whenever there is a fire. Because hydrogen is lighter than air, it diffuses quickly and it collects in the corners. Like Fukushima, that major disaster, why it happened is the hydrogen was collected in the rooftops. Right? When the spark happened because of whatever, the whole rooftop blew out and that contributed the entire Pacific coast, which still we are suffering. Hydrogen is extremely flammable with a very low ignition energy and a wide range of flammable fuel and mixture. It's about 4 to 75%, if I remember correctly. So, which means the entire range of hydrogen is flammable. It is not like LNG, which is 5 to 15%. So, if you have more than 15, it may not ignite. But hydrogen is not that. If you have a liquid hydrogen and a small spark or a tiny friction hotspot, it will ignite, and that will be the explosion of hydrogen is different. LNG, it produces a luminous flame, right? A lot of carbon is there. So you can actually see the fire. In hydrogen, you don't see the fire, it is invisible, very pale blue flame. But the heat is intense. Once I know in one of my factory days in Asia, long time back, one guy got his hand burnt because he was trying to close his hydrogen cylinder valve, which was on fire. But the flame was not seen. So the moment he touched the hydrogen, very high temperature, he got seriously burned. Burns with pale blue flame, almost invisible flame, requiring a special flame. So hydrogen, any installation, whether filling station, use point, or wherever in the production plant, the flame detectors and the gas detectors, that is the hydrogen specific gas detectors, need to be installed in all the critical places, particularly in the high places, because that is where the hydrogen accumulates and the danger spots are formed without people knowing it. And also, hydrogen is a very strong aspect set, like nitrogen. But nitrogen is same density more or less air. So, it doesn't go up. Hydrogen goes up and fills from the top. So it will come slowly, and then suddenly you are in hydrogen, where your part of the body may not be hydrogen. So it can be felt.